Imagine strapping into a spacecraft and accelerating to nearly the speed of light. You fly around the cosmos for what feels like a few days to you, but when you return to Earth, decades have passed. We know this happens because of Albert Einstein's theory of relativity. He showed us that time is not a strict universal clock ticking lay in the background. It is a flexible fabric interwoven with space itself. Physicists call this time dilation. The rate at which a clock ticks actually changes depending on two things. First, special relativity dictates that moving at extreme velocity slows your clock down relative to stationary observers. Second, general relativity shows that sitting in a region of intense gravity does the exact same thing. Traveling into the future does not require science fiction magic. It is a proven physical mechanism dictated by the laws of the universe. You don't even need a spaceship to see it happen. You just need the smartphone in your pocket. The Global Positioning System, GPS, relies entirely on time dilation to work. This data visualization breaks down the math happening right now in Earth orbit. Because GPS satellites are flying at 14,000 kilometers an hour, velocity slows their onboard clocks down by 7 microseconds a day. But because they sit high above Earth's center of mass, the weaker gravitational pull actually speeds their clocks up by 45 microseconds. Combine the two, and the satellite's clock runs exactly 38 microseconds faster than a clock on the ground every single day. To make sure your map app works, scientists have to step in. They physically adjust the ticking rate of the rubidium-based atomic clocks inside these satellites before they even launch, perfectly offsetting that continuous relativistic drift. If engineers ignored this math, the timing signals would instantly desync. Within a single day, global navigation systems would build up a 10-kilometer error margin, making them entirely useless. So we are already engineering our way around forward time travel on a daily basis. Which leads to an obvious question. What do the laws of physics say about putting the machine in reverse? General relativity technically contains mathematical loopholes that permit backward travel. Physicists call these closed time-like curves, specific paths where the fabric of space-time twists and loops backward onto itself. Theoretical physicists have proposed a few cosmic machines that could create these loops. The first is a Kerr black hole. Unlike a static black hole, a Kerr black hole spins, dragging the fabric of space and time around with it, like milk swirling in coffee. If a ship could precisely slip through the core of this rotation, a structure known as the ring singularity, the math suggests it could drop the traveler directly into their own past. Then there is the Tipler cylinder. This concept requires an incredibly dense spinning cylinder. As it rotates at near-light speeds, the intense gravitational field would tilt the light cones of approaching objects backward, twisting their timeline into a loop. This diagram illustrates the third theoretical machine, traversable wormholes. It maps a cosmic tunnel connecting two eras, but taking this trip has strict conditions. The traveler cannot encounter an event horizon, and tidal gravitational forces must remain low enough so the ship isn't torn apart. That is what the equations allow, but translating those equations into physical engineering reveals extreme roadblocks. Take the Tipler cylinder. For the mathematics to successfully create a time loop, the cylinder must be infinitely long. In a finite universe, building an infinite structure is physically impossible. This section of the research paper details the primary barrier for traversable wormholes. Keeping a wormhole throat from instantly collapsing requires exotic matter. This is a hypothetical material possessing negative energy density, something that outright violates our current models of energy. The math of general relativity permits backward travel on paper, but the material requirements render it impossible to build with our current understanding of the universe. Even if we build a machine, we hit a logical wall, the grandfather paradox. What happens if you travel backward and prevent your own birth? If you were never born, you couldn't build the time machine, meaning you never traveled back to begin with. Physicists rely on two main theories to resolve this. The first is the Novikov self-consistency principle. It argues that the universe physically prevents paradoxes. If you tried to cause a paradox, the laws of probability would ensure your gun jammed or you slipped. The events are fixed. The second solution is the Deutsch model. Relying on quantum mechanics, this theory suggests that the moment you arrive in the past, your timeline fractures. You enter a newly created parallel timeline where you are free to alter events, leaving your original universe untouched. To solve the logic of backward time travel, Physics forces us to choose between two extremes. Either the universe strips us of our free will, or it generates an infinite number of parallel realities. Faced with these paradoxes, physicist Stephen Hawking proposed a final verdict: the chronology protection conjecture. He suggested the universe possesses an ultimate defense mechanism against causality loops. The instant a wormhole connected the past to the future, quantum vacuum energy would flood the system. This energy would cycle infinitely through the loop, instantly overloading the tunnel and vaporizing it in a fraction of a millisecond. Through time dilation, the universe freely allows us to ride the river of time forward. But between extreme engineering barriers and absolute quantum defenses, the laws of physics ensure we can never swim upstream.